So Dr. J here. And today, what we're going to do is we're going to talk about how to complete our results section and how to analyze our data, and then how to write our discussion section for our inclined surfaces or inclined plane mini lab. Okay, so let's get started. Oh, I think teachers are allowed to unmask themselves in their classrooms now before students arrive. So I'm unmasked. Okay. So yeah, I have a face. I have a face. I have a face. All right, here we go. So let's go to our data sheet. Okay, so this is what your data sheet looked like before you got started with it, right? And ultimately, we're going to want it to look about like this. Okay, so how do we get there? So I'm going to go ahead and copy these data, and I've copied these from a student. Okay, so these are not my data. I am openly acknowledging that I have copied them from someone else, but I'll go ahead and analyze them. And so whoever's data these are, right, you're going to get to see your data analyzed right away. Okay, so the first thing we want to do is we want to calculate the average time of descent for the first 3 trials, right? So I'll copy this and I'll paste it over here. Okay, so boom, right? And then I'm gonna have to make this little column a little bit bigger. Okay, average time of descent in seconds trials. Okay, and the first trials I had were trials 1 through 3. All right, and so what's the average? Oh, and I always like to have everything centered. So I'm gonna center align everything. I'm gonna do that for the whole thing. Center align, good, okay. So if I wanna calculate my average for those first 3 trials, and those are these trials here, right? I have to notice that these trials are in column C, rows 4, 5, and 6. So I type in equals average, and they might be different for you, right? So you have to pay attention to which cells contain your times, right? But I go average from C4 colon C6, okay? And then I go ahead and hit enter, and I get my average. And now I'm going to go through for trials 4 through 6, okay? And trials 4 through 6 are in these cells, so C7 through C9, so equals average, C7, C9, boom, okay? And then lastly, 7 through 9, okay? So we've got 7 through 9, and those are C10 through C12. So equals average, C10 through C12. Okay, boom, like that. All right. Seriously? No, something's wrong. Oh, it says C10 minus C12. Sorry, it needs to be a colon. C10 through C12. There we go. Okay. So even I can mess up sometimes. So you use the colon to define the range. All right. Now, the next thing that I want to do, and let me double check that I got the same values last time I did. Now I want to calculate my acceleration for my golf ball, okay? Because I've got time and I've got distance data, so I should go ahead and calculate acceleration, right? So I'll go ahead and write on the screen. We remember from our lecture, right, that distance equals 1/2 times acceleration times the square of time, okay? So what we're trying to do is we're trying to solve for acceleration. So we multiply both sides by 2, and then we divide both sides by t squared, and we get 2d divided by t squared equals acceleration, okay? So then we're basically just gonna plug that formula in over here. So we're gonna go, this guy equals 2 times the distance. Well, where's the distance? That's just that's just in any of these cells here. So any of these cells right here, okay, contain the distance, right? So I could go with E4, E5, all the way up to E12. Okay, that's where my distance is. So what I do here is I type equals 2 times E4, right? And it's divided by the time squared. And I'm going to use my average time, which is right over here, okay, 1.07. So I'm going to refer to cell C16. So my distance, right, is this guy, and my time is this guy, okay? So I have to square that time. So let me go ahead and get this guy figured out. So that is times C16 to the power of 2, okay? Times C16 to the power of 2, all right? boom, okay? And then there's my force, right? And then this thing's kind of smart, actually. Like it's actually really, really smart. Yeah, I think this thing actually gets it right. So I can actually autofill here. That's the smart, right? E5, it doesn't matter if it's E5 instead of E4. Yeah, and it's using the right cell. Yeah, that's smart. It just autofilled it for me. So that's perfect. But you've seen how to compute the acceleration if you need to, okay? So now we've got our acceleration in meters per squared second, all right? I'm gonna go ahead and clear that out. Now we go over here and we want the mass of the golf ball. Okay, and this I'm just gonna copy straight because we know from our last time, and if you'd like to, you can feel free to go use the balance to remeasure the mass of your golf ball. But for just about all of us, anytime we've wanted to get the mass of a golf ball, so copy, and then over here, Control C and then Control V, we've gotten roughly 46 grams, usually 45.5 grams or 45, excuse me, 0.2 or 0.4 grams, something like that. So we're gonna call that 46 grams, just round up. And that comes out to 0.046 kilograms, okay? Because there are 1,000 grams per kilogram, so we have 0.046 kilograms, okay? So you can use that value or you can go measure with the balance if you would like, all right? And then now we're gonna calculate our measured force, okay? And remember, force is just mass times acceleration. So we've talked about this and we've done a lot of computations, but it's good to review, right? So according to Newton's second law, force equals mass times acceleration, okay? So we've got the mass here, we've got the acceleration here. We just need to multiply those two columns together, okay? So if I wanna go ahead and create a column that's called measured force, I'll go ahead and just copy this title here, copy, paste, right? That's just gonna be equal to, okay? That's gonna be mass times acceleration, so E16, that's that cell right there, times D16, okay? And then it'll autofill for me, and that's correct, okay? It does the correct autofill. Now I've got two last things to do, okay? So now I'm actually gonna calculate an expected force. And the way I calculate my expected force is to multiply the known gravitational acceleration, okay? So little g equals 9.8 meters per second squared, okay? Meters per, I'll connect that there, so second squared, okay? And what you actually do is you multiply it by this height divided by this height. That ends up being the sine of this angle, okay? So we may talk more about trigonometric functions like sine later on, but right now we're just gonna multiply by this divided by this to get our expected force, okay? So my expected force, so force expected equals G times, okay, the height divided by the length for any particular set of trials, all right? So this one, what I do is I'll go ahead and copy that little expected force, Control C, Control V, okay? And what I type is equals 9.8 times, okay? Oh, and I have to multiply by mass too, sorry. So you have this, and you have to multiply by mass too, sorry. So also times mass, okay? So times the mass as well, sorry. So it's mass times expected acceleration. So I type 9.8 times the height, which is that's in cell D4. So D4, okay? Divided by E4, because that's the length of the ramp, all multiplied by the mass, which is E16, okay? And now I'm gonna do this again, okay? So this equals 9.8 times, this is gonna be, now I have to go with a different set of values. So this is gonna be a new height for these trials. So 0.25 divided by 0.445. So I type that in here, okay? 9.8 times 0.25 divided by 0.445, okay? All times the mass, which is E17, okay? I get another expected force, and no, I'm not gonna let it autofill. This autofill won't work, okay? So here I do the last one. So now I'm worried about these, actually this one just gets replaced. Okay, like, so in this case, I'm just gonna use 1. So really, they should be the same. This should equal this, okay? So I'm not gonna use those values directly. So all I have to type here equals 9.8 times the mass, okay? Because the ball is falling straight down, so it's just gravitational acceleration times the mass, which is 0.046. So we'll go with E18 here. It doesn't matter which mass we use. So E18, boom, right? Now the last thing I'm gonna do is calculate, so let me clear all this out. I'm gonna calculate my percent error, okay? So I'll just copy that little percent error, Control C, Control V, okay? And this one is equal to the absolute value, like that, okay, of the measured force, which is in F16, divided, or no, actually it's the absolute value of the quantity expected minus measured divided by expected. So it's G16 minus F16, all divided by G16, okay? And that thing's gonna autofill correctly, all right? So those are some really large percents error, okay? Those are some like really large, oh, and we have to multiply by 100. So let me undo that, all times 100, boom. Okay, then I autofill, okay? And if you notice here, I've got a bunch of values that have like crazy numbers of decimals. So I'm just gonna use this little guy over here. So here's how I decrease the number of decimal places, okay? So I'm just gonna go ahead and decrease the number of decimal places. So this is all, let me go for the whole sheet. So I have to click there for the whole sheet, and then I can decrease the number of decimal, whoop, 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 that went crazy. I like it about like that with 3 decimal places. And then my trials kind of go crazy. So this has to be reset. It gets crazy, like the computer breaks. So 1 through 3, the algorithm breaks, 4 through 6, and then I have to type 7 through 9. Okay, like that, and then I'm good again. And then everything else makes sense. I mean, I could be kind of a stickler and say, well, it doesn't want to allow me to get rid of the decimals. That's fine, okay? So, okay, so that just kind of cleans up the look, okay? And now we're done with our data, all right? So let's talk about our last results question and then our discussion section question, okay? So let's go ahead and take a look at this guy. So you have one more results question to do, okay? And it says, as the ramp incline increased, how did the measured force acting on the golf ball behave? Okay, so if you look here, the ramp incline increases, okay? And as that happens, the measured force increases, okay? So same kind of relationship, or actually a different relationship than we've seen. We've seen time decrease, okay? Time has decreased in this direction, but measured force is increasing when the ramp incline increases, okay? So force is actually increasing with an increase in ramp incline, okay? That's what you're seeing in your data. We're all going to see this in our data, okay? Unless we've made a mistake on data entry. So now let's take a, so that's how we answer this question. Now let's take a look at this one. Given that gravity pulls objects toward, let me blow this up a little. So given that gravity pulls objects straight toward the center of the earth, or as we might say in casual conversation, straight down, why do you think that the measured force acting on the golf ball increased as the ramp incline, that is the slope, increased, okay? And that's just for you to think about. Go ahead and answer that in your own words, however you see fit, okay? There aren't a lot of wrong answers to that question, all right? I want you to think, okay? And just do your best to answer it. We will get there, okay, in our next unit, but right now I want you to think, all right? So in general, second question, do you think that objects are more likely to roll or slide down steep inclines or shallow inclines, and why do you think this? Okay, so here you need to reference your data, right? And what you've seen is that the steeper the incline, right? The steeper the incline, okay, the quicker the descent, all right? So you have data that can allow you to speculate about how your data might relate to all of the data in the world, right? And there's really no good reason for you to think that the steeper the incline, the slower the descent would be. Okay, so you know from your data and from your experiences in the world, right, that the steeper the slope, okay, the faster the roll. Your data backed this up. Okay, reference your data to answer this question. All right. And then reflecting on your percent error values, do you think you could have obtained more accurate data? If so, how so? Okay. And then one last thing that I'll show you is, okay, you can really easily turn these guiding questions into sentences so that you can quickly do your lab report, right? So what you want to do with one like this is you want to say, given that gravity pulls objects toward the center of the earth, or as we might say in casual conversation, straight down, I think that the measured force acting on the golf ball increased as the ramp incline increased because, and then you just put your answers there, right? And you can do those same sorts of things, those little minor adjustments to the guiding questions to turn them into sentences with all of these sentences, okay? So that's gonna help you write your lab reports a little quicker. And I know that some of us have been getting sort of hung up because it is a new format for us, et cetera. But you don't have to be overwhelmed by the writing, okay? I've written this so that the writing should be really easy for you, all right? So that's your heads up for today, okay? We're just wrapping up this mini lab. As always, good luck, and may all the forces be with you.